or tertiary winds? Tertiary winds are tertiary circulations, right? So these tertiary winds and tertiary circulations comes into picture when primary and secondary circulations fail to be existent at that particular place. In India also you have these local winds, across the world also you have local winds. Okay? Now let's try to look into these local winds, and they have different names for different winds. But the principle in that local winds is more or less the same. Broadly, these local winds or tertiary circulations, they can be divided into cold local winds and hot local winds. Cold winds or warm winds. Right? So first let me show you these winds. Just a minute. See, across the globe, they are with different names. Okay? So these are some names which you need to remember. I'll underline what names to be remembered, and it is not important that each and every local wind that you need to learn. Only few local winds you are supposed to learn. Let's try to understand what are these local winds that you should be learning. Number 1, it is Chinook. Okay? That is Chinook winds. Number 2, Foehn. Next, Harmattan. Sirocco. Mistral. Bora. Levant. Okay? So these are the names that you need to remember. One is Chinook. Chinook is a local wind which is found in the western part of the USA. Okay? Mistral in the France or the Iberian Peninsula region, France and all that region. Levant on Iberian Peninsula literally. Foehn, Sirocco. Sirocco is in Africa. These winds travel from the desert and they pick up the moisture in the Mediterranean Sea, and then they shed that moisture in the Europe. Right? Other one is Harmattan. अभी नाम याद रख लेना, बाकी I'll explain how these winds are formed. And when it comes to India, nor'westers, mango showers, blossom showers, Kal Baisakhi, Lu. These are the 4 basic minimum local winds that you need to remember. Right? Now first let's try to understand what exactly are local winds. See, local winds are those winds which can be formed using the local weather conditions. Okay? It do not have any significance with that of the global atmospheric circulation, but they can be formed because of the local conditions, right? Now, across the earth, there is one common local wind, that is land breeze and sea breeze. Now, what is this land breeze and what is this sea breeze? Let's try to understand how they are formed. So, for India, you have nor'wester winds, mango showers, blossom showers, and Lu. Kal Baisakhi, right? For USA, Chinook, I told you, okay? Chinook, and other one is blizzards also, you can remember, right? Mistral, Levant, Sirocco, Harmattan. Harmattan matlab literally doctor. Doctor, this is called as doctor winds. Harmattan is called as doctor winds. Now, why is it called a doctor? I'll tell you. Now, Bora, Foehn. Now, let's quickly move towards the first common local wind across the globe, that is your land breeze and sea breeze. Okay. Now, how come this land breeze and sea breeze develop? Let's try to see. See, firstly, when you are sitting next to the coastlines or on the beach, during the daytime, the wind will be coming from one direction, that is generally from sea towards the land. But at night time, when you are facing the sea and standing or sitting, you will see that the wind will be blowing from backward, that is land towards the sea. Right? Now, every day this particular situation changes. Now, till what distance this wind's direction will change? If this is the coastal area of India. Now, my question is, if you are present somewhere here and this land breeze and sea breeze, they'll have their impact till how many kilometers into the interior? It can go up to 60 kilometers interior also. 60 kilometers interior also, it can have its own impact, right? The impact. See, during what happens in the land breeze and sea breezes, first, let's imagine that this is your sea. Right? And this is your land. Imagine this is a coconut tree. Right. Now, this person during the daytime, how does the wind moves is, the wind moves from sea towards the land during the daytime. Now, why? Let's try to understand this. This is your sun. When the sun starts to heat the land and water simultaneously, who gets heated fast? Land gets heated fast. This particular principle I've told you earlier. Why? Because in a solid, it is always, if this is a solid, the particles are very densely packed and these particles cannot move. But in the water, this water, as soon as they get heated, they distribute the heat by the water moving in circles. Okay? Convections. So this is how, that's the reason why the glass of water or the 1 liter of water, it takes more heat to heat by 1 degree. But the same heat, if with the less amount of heat, this will get raised its temperature by 1 degree. So this is called as specific heat of water. That's why land gets heated quickly and land gets cools quickly. Remember this? right? Land gets heated quickly and cools quickly. Sea gets heated slowly and cools slowly. This is because the specific heat of water is more as compared to land. That means water needs more temperature to heat or raise 1 degree Celsius, or else the heat required to raise 1 kg of water by 1 degree Celsius is more than the heat required to raise 1 kg of water by 1 degree Celsius is more than the heat required to raise 1 kg of solid by 1 degree Celsius. Right? Clear? This is the reason why you will see that the water gets heated slowly and land gets heated quickly. Now when the land gets heated quickly, it is having more heat. Okay? More heat. Now when you have more heat, what kind of pressure do you have? That means high temperature you have during what time? During daytime. So because of that, you will see here evaporation starts. Here rising of air starts. The air starts to rise. You know low pressure में क्या होता है? I told you the vertical column of the low pressure. Here, the wind starts to rise in the upper direction. Right? Now, if the wind is starting to move towards the upper atmosphere, don't you think that the winds in the nearby area, they will start to fill the gap? I hope everyone knows what do you mean by filling the gap. Filling the gap means literally if the air is getting lifted here, there shouldn't be any air at this particular point. Right? At this point, there should not be any air. But continuously the air is moving from somewhere else. That means the gap that was created here is actually being filled by the air near and dear. So compared to this particular area, you have high temperature, the water gets heated slowly, the water will have cool temperatures, right? So during the daytime, the water has cold temperatures as compared to land. Right? Water has cool temperatures as compared to land, and that's the reason why the water is having comparatively high pressure. Now when you have high pressure and here you have low pressure, the winds will start to move in this direction. Right? Why? Because the air that is risen, it will now diverge and it will start to sink here. It is having high pressure because the air is sinking and the air is diverging. Okay? The air is sinking. It is diverging. Now this divergence of air which is there, it will start to come towards you standing on the surface near to the coastal area, and this fellow will experience the wind from the sea. Now this is during morning. And this is called as, what is this called as? This wind is called as sea breeze. Right? Exactly at night time what happens? The sun is gone. When the sun is gone, who gets... I told you that land gets heated quickly, cools quickly. As soon as the sun is gone, the land will start to lose its temperature, but the heat that was there with the water will remain. ठीक है? The water retains heat and the water gets cooled by early morning. ठीक है? 3 बजे, 4 बजे, 5 बजे. That is the time when the water gets cooled. Right? More cooled. And morning 5 o'clock or 6 o'clock the water will be cold. Right? As soon as the sun comes, it will start to get heated, but it will be heated slowly. Right? Water will retain the temperature. So, night time what happens is, exactly opposite of what we have learned. So, again, just imagine that you are sitting here. Look, night time, land gets heated quickly and land cools quickly. Daytime it was low pressure. Now it will turn out high pressure and the water will retain the temperature of the day. So here, are you clear with this? The water will retain the temperature of the day for longer time as compared to land. Thus, it acts as low pressure at night. Right? Okay. Now, land, what happened to the land? Land loses the heat faster than water. Thus, the land is more colder than water. Therefore, land has high pressure conditions. Okay? Now see, the conditions are completely reversed. Who is more hotter? Water. Now water will act as low pressure. Therefore, water, they will start to evaporate or rise. And here, as there is gap that is created here, and this gap shall be now filled by the sea breeze. This gap will be filled by, this is called as land breeze, this is called as land breeze. Now daily reversal of these winds, it is called as land breeze and sea breeze. Why? Because the wind is moving from land towards the sea. Yes? Whole year, every day. Every day I am talking about. Okay? Every day. And coastal areas, it will be very humid. Why are coastal areas so humid? Look here. You go and sit in Chennai, Visakhapatnam, in Kolkata, elsewhere, across the coastal areas, even in Goa also, the humidity is too high. Why it is so high? Because look here, there is continuous evaporation going on. Land, air is moving and the water is being moved inside in the form of water vapor. Salt also comes into your picture. That's why those people who are standing here, they'll feel too much of moisture is there in the atmosphere. That is nothing but your humidity. Mumbai में जाओ पसीना आते ही रहता है. Right? It is this reason. And the more the air moves on the sea, the more is the evaporation that will take place. The more the air moves on the sea, the more is the evaporation that takes place. Right? This is how it is. Now this is called as land breeze. So this is called as sea breeze. And this is called as land breeze. Land breeze at night time, sea breeze in the morning time. Clear? This is nothing but your local winds. Now till what distance the sea breeze enters into the land? 60 to 80 kilometers tak ja sakte hai. Same is the case. From 60 to 80 kilometers the wind will be flowing into the sea. Right? So those people who are staying next to the coastal areas, evidently the impact can be seen up till 40 kilometers tak clearly impact dekhte hai. And rest of the time they might feel occasionally. Right? Every day up till 40 kilometers they can see variation next to the sea, whosoever is staying. Next. Yes. Industrial? Chennai. Pollutants. See, now his question is, in this context I'll ask a question that let's take cities like, let's take few cities. One is Delhi, other one is Bombay, Kolkata and Chennai. Why is, as compared to Kolkata, Mumbai, Chennai and Hyderabad, why the city of Delhi has high pollution? See, if you can say that, sir, industries are more in Delhi, more industries in Chennai and Mumbai, the industries are more. In fact, Kolkata mein industries are more. Why is that? The pollution in Delhi is more as compared to the pollution in Maharashtra, that is Mumbai, Chennai and Kolkata. It's not low pressure area. Basically, what is common across Mumbai, Chennai and Kolkata? Coast and coastal area. Coastal area में क्या हो रहा है? Can you see on a daily basis the wind is moving, the wind comes and the wind goes, right? With that what happens? The pollutants can be carried into the sea by the night time. Okay? The pollutants can be easily settled down. But when it comes to Delhi, Delhi is a landlocked place. In Delhi, what happens is that the air gets trapped, excess amount of heat. The air cannot move that easily. But यहाँ पे रोज every day you get to see 50 to 60 kilometers of air which is there, it is getting circulated and the pollutants will also get circulated. Right? And the humidity is more. So rainfall will also be comparatively there. Right? In one or the other form. Or else due to heavy moisture they settle down easily. Got it? That's the reason. Now the next wind that you need to know is local wind, is Chinook. To understand Chinook, first you need to know about the USA. Look here, on western side of USA, you have these mountains. ठीक है? Rocky Mountains कहाँ जाता है? ठीक है? Likewise, on the western area, you have western mountain ranges. There are cold winds that will be coming from the western areas, right? And these cold winds, when they cross over the mountain, there are certain changes that are happening. Now, what are these changes that are happening? Let's try to understand. The temperature variation between the western side of the mountain and the eastern side of the mountain. Suppose let's take one of the mountain and try to study this. Okay? Let's take one of the mountain here. Imagine this is a mountain. I took one of the mountain and exaggerated this mountain. See, usually if there are cold winds which are coming from the west, I always call, if I am standing on this side, this is your west, this is your east. Why? Because sun always rotates from west to east. Okay, this is how the earth, not the sun. The earth always rotates from west to east. So I call this as west, I call this as east. Now, to make it little more easier, what I'll do is I'll show you a small diagram. Usually, the cold winds in USA come from the west. Now look into USA. If you open your atlas or look, you will see that USA is present in westerlies belt or easterlies belt. USA is present in westerlies belt or easterlies belt. Online? Because of location. Very good, Munendra. It is present in westerlies belt. Right? If USA is present in the westerlies belt, winds always come in the angle of west to east. Yes. Look here. Look, this is Tropic of Cancer, this is Arctic Circle. Now between these two, what kind of winds do you have? Westerlies winds, the winds that come from west to east. If I am having mountains here, especially the mountains that I am going to show you now. Can you see these mountains? In your Rockies करके लिखा होगा. In your atlas, you will find. Now these mountains, on one side, the winds that are coming here are very, very cold winds. These are cold winds. And imagine that you have a very big mountain here. The temperature here is 10 degrees, minus 10 degrees Celsius. Right? Now these winds, as and when they start to rise. When they start to rise, what happens? Temperature will decrease more, and then it has to rain, and if at one or the other temperature it has to rain, dew point it will reach. So minus 10 ka aata, it's 10 degrees Celsius. Very, very cold winds. Now as and when they start to rise, the air starts to moisture, the relative humidity which is there, it will be full, or the humidity gets to saturated point. Now at one or the other point it will start to rain, and the cloud starts to rise, and they'll lose the moisture. Okay? And at this particular point, the temperature reaches to minus 12 degrees Celsius. Because it is also gained a height of near about 2 to 3 kilometers. So these winds, as soon as they come onto the other side, they are descending. What is happening here? Adiabatic heating. ठीक है? Or else, if I simply say that as soon as they come onto the other side, they start to get heated. Why? Because they are losing the heat and already they lost the moisture. Altitude भी कम हो रहा है on that side. Firstly, they are losing the moisture here, these winds or the clouds. Now, they have shed all that rainfall, they are colder here. But from now on the other side, when they are moving on to the eastern side, they'll lose that heat. Okay? Sorry. They'll lose that cold temperatures and they'll start to gain the heat. Now, this gaining of heat, these winds are called as Chinook winds. Chinook winds are actually considered good for the people who are living on the eastern side. Look here, the temperature is 10 degrees Celsius and 18 degrees Celsius. Those people who are living on the eastern side of the Rockies, they'll experience 18 degrees Celsius, and those people who are living here, they experience 10 degrees Celsius. Chinook are those winds, cold winds, when the cold winds get converted into a warm wind. Now here, this side in which the clouds or the winds are moving, this is called as windward side. Okay? On the other side, this is called as leeward side. Do not have rainfall. Yes, no rains and dry. And windward side, you have good rains plus cold temperature. Here, no rains, dry plus warm. Right? This is what is your Chinook wind. Chinooks are when on one side of the mountain you find cold winds, on the other side of the mountain you find warm winds. That is because as and when the wind starts to rise up, they'll lose the moisture, and the lost moisture is the wind which is there now gets heated because it is losing its height. Clear? Can this happen in India? First, India में होने के लिए you need to have westerlies, very cold winds. We have windward sides and leeward sides. Local Chinook winds are there in India. In mountainous regions of India, especially in Himalayas, in few areas you will find Chinooks. Aravallis nahi, it is in the North Himalayas, Himachal, North, Kashmir area and all. Seasonally you will get to see one or the other day. Maybe cold, it is very cold on one side and little warmer on the other side. A variation of 5 degrees can be seen. A similar kind of effect. क्या हुआ? A similar kind of effect, if it is happening in the Europe, you'll call it as Foehn. Once take a minute and try to read what is written here. Take a minute and try to read what is written here. Cool, moist air approaches the windward side of the mountain. ठीक है? Next, clouds form and rain falls, causing the air to get drier as it rises. And then dry air from higher altitudes can join in. Dry air, the air here also it can move, right? For example, it can be jet stream also, it can be anything. Usually, if the wind is moving in this direction, if it is hitting with the mountain, it will create a turbulence, right? The wind will not move in straight way. Rather, the wind ऐसे move करता है, right? This is called turbulence of the air. Turbulence will not always happen because of clouds. If you have undulating topography at the ground level, then instead of the wind moving in a straight line, it comes and hits here. The air moves like this, maybe irregular mannerly it moves. That is called turbulence. If suppose an aeroplane is in the turbulent zone, it will start to wobble. Sometimes this can happen because of the extreme heat that is happening over this particular mountain. Imagine hundreds of mountains are there, thousands of mountains are there, like Tibetan Plateau. So Tibetan Plateau is full of mountains. The wind that is moving over Tibetan Plateau, सो रॉसबी वेव्स के साथ मूव करता है. टर्बुलेंस के साथ स्पीड इंक्रीज होता है हमेशा. नाउ सी हियर, that means at points it can, at some points it can increase and at times it can decrease also. Now come and look here, turbulence increased, now the wind starts to descend. Same, there's nothing change here, but I've put that in the form of content so that it will be easier for you to understand, right? So please quickly make this diagram. This is called as Foehn, Foehn winds. Now where is this Foehn found? Foehn is found in Europe. Where? It is in Alps. This is your Alps, Switzerland. The wind starts to come in this direction and it descends to Italy and all. So this is what is your Foehn wind. Quick. Yes. Is it also called snow eater? See, Avijit has asked a question, sir, Chinooks are called snow eaters. Yes, they are called snow eaters. Now, once let me give the explanation here. Look, before the onset of the Chinook winds, the eastern side is also full of snow, usually in the months of winters in USA and so. As soon as the snow comes in, as soon as the Chinook comes into picture, what is the temperature? 18 degrees Celsius. Earlier the temperatures used to be very less. There used to be snow here. Now Chinook comes and eats the snow. Right? That's why it is also called as snow eater. Only on the leeward side. I'll tell you the Indian conditions, how in India this windward and leeward side operates. And remember this, leeward side always has no rain or very less rain. Once you are done, let me know. Dry air from higher altitude is because by the time this air reaches to the top, either it might have shed its moisture and the air will be dry here. Okay? Especially at the height, at this height. See here all the moisture it might have shed. The air that is present above and all, it will not have moisture. Okay? It is cold air. That's why it is written as dry air from higher altitudes. Altitudes means high height. Can join in. Warm air से low pressure होता है. See, pressure is increased with respect to what? Usually, you are confusing again with vertical pressure with horizontal pressure. When the air is sinking, what kind of pressure you have? High pressure here as compared to this. Vertically it is talking about. It is not talking about the pressure here and the pressure here. Now the next winds are called as Santa Ana winds. This I did not give you, but this is an addition, Santa Ana. Now what are Santa Ana winds? Let's try to see. See, Arizona desert will be there in your atlas. Just have a look in USA map. Arizona desert, California desert. Did you find Arizona? You'll find here. On the western part of USA, it is like this. See here. Now this is where you find mountains, and Arizona desert is present here. Right? Behind the mountains. Rockies. Behind the Rockies mountains, you will find this Arizona desert in the main map of USA. So, look here in California, and so you get to see these winds that are rushing from the desert area towards the mountains. Okay? Imagine this is a mountain. The winds are rushing down the mountain. Right? And there is a highway. This is called as the national highway of the USA, one of the national highway. So what happens in this particular incident is that as the wind is descending, do you get to see the cold air descending or warm air descending? It becomes warm. It is leeward side and the wind becomes warm. And here you have tropical dry deciduous forests. ठीक है? Tropical dry deciduous. जहाँ पर पत्ते गिरता है, ड्राई होता है सीजनली. हाँ, in mountains you will find dry forests, not so wet, and the leaf will litter, the leaf will fall every few months. So as and when this air starts to descend, the wind starts to get heated, and sometimes it will lead to forest fires in the lower regions. And this warm air will not let the travelers to travel open air. Okay, it becomes very, very difficult for the travelers in that. It is extremely heat. The truck drivers, all of this, the accidents are more just because of the heat. When it is said that whenever the heat is more, the irritations are more. And in that irritations, the accidents are more on this particular road itself. Now these winds are called as Santa Ana. Once, let's see what are the points that are written here. It says that in addition to increasing the threat of the wildfire, Santa Ana winds can cause trouble for drivers and pilots in the southern California. Okay? It is descending from the hot desert, Arizona or the eastern side. Once a wind starts to descend, right? The wind starts to descend downward. It is like this. This is what is your California, right? And here you have mountains. The air from here, it will start to descend downward. Now these are seasonal winds, local winds. Remember, local winds do not adhere to primary circulations and secondary circulations. So these winds, when they descend, this entire stretch of road which is there on the western side, this stretch of road which is there on the western side, now these winds, when they descend, they'll create problems to the western part of the USA. That is nothing but your California. Now let me show it to you here. So this is all mountainous area, and this is also a desert. From here, they'll start to descend like this. And it will create wildfires. Traveling in this area is very, very difficult. Right? Now what is Santa Ana wind? Santa Ana is a descending wind that cause large-scale wildfires and intense heat, strong winds. It can create turbulence. Right? This is the local wind which is found in the California. One is Arizona desert and California desert. Arizona and California desert. Quickly take this down. Negev desert भी है यहाँ पर. NEGAV, Negev. And after this I have to give the notes also. Okay? I'll dictate the notes also for yesterday. Yes? This one. Usually in the high pressure areas is nothing but deserts and all the conditions will have high pressure during the winters. But please don't write this first point. It is not relevant to you. Okay? First point mat likhna. Because to understand this, we have to spend some more time. I have to explain geomorphology, the local conditions there. So until then, just learn it as a fact. I'll explain in the further time period. Geostrophic winds are nothing but your atmospheric jet streams. NCERT it is written, right? I'll explain that. Wait. Spell. Canyons. Geomorphology. I'll explain. Not now. Canyon is a landform. Grand Canyon सुना है? Canyons are deep valleys, which are U-shaped valleys. Rift Valley type है, but Rift Valley is V-shaped valley, but Canyon is a U-shaped valley. That's the only difference. Done? Can you repeat Purav Saini, Santa Ana? See, basically Santa Ana winds are those winds which are descending from desert. Okay? Imagine there is a desert here. From the desert, the winds are actually moving downward. And due to that, the descending winds which are there, they catch the fire. They help in creating the forest fires. And descending winds always have high temperatures. These extreme high temperatures will not let the travel easy in the local area. These are called as Santa Ana winds. Santa Ana winds, simply you need to remember that they are descending winds from a desert. That's it. Shaurya ka question hai, sir, this is a westerly area. How come winds are coming from east to west? Now, what are we discussing here? Primary winds, secondary winds, or tertiary winds? Tertiary winds. Now, what is the definition of tertiary winds first? When do they occur? Secondary and primary fail. You told me that only when the local wind, only when the primary circulation failed, that is westerlies failed, then they came into picture, no? Got it? These are because of the local conditions. Because in the deserts and all, what happens is that there will be extreme temperatures. Sometimes it can disrupt the westerlies belt. Right? That's why. This you'll get little more clarity when I'm going into the advanced geography. Abhi ye fact ki tarah yaad karna, because that needs an explanation that I have to take up in the further time period. Then at the end I'll discuss while discussing the mapping also. Right? So Mojave, Negev, ye sab desert se, look here. This is how the wind moves. Right? Negev desert, California desert, Mojave desert. In these winds, they start to move out. Next is Harmattan. Now what is Harmattan? Harmattan literally means doctor. These are called as doctor winds. Now where do you find it? You find it in Africa. See, this part of Africa, which is the equatorial part of Africa, I told you every day it rains, right? When there's too much of humidity that is present next to the equator. In case of extreme humidities, what happens is that you will have too many diseases, especially skin-related diseases. Okay? Humidity is a cause for many diseases that will not get cured easily. So people of Africa, their health conditions are not good, their economic conditions are not good. So the heat is too high during the months of summer. And I also need to explain the ITCZ zone. Now, what is this ITCZ zone? Where the easterlies of the northern hemisphere and the easterlies of the southern hemisphere, they come and meet. Now that is called as ITCZ zone. This ITCZ zone is not always a straight line. Okay? Why is it not a straight line? See here. I'm going to explain you the concept of ITCZ again. Only then you'll understand this particular concept. This is equatorial low pressure belt, and this is subtropical Arctic. See here. What are these? Which easterlies? Northeasterlies. These are northeasterlies. And what are these? Southeasterlies. And this southeasterlies and northeasterlies, where are they meeting? Equatorial low pressure belt. I'll also call this as ITCZ, which means intertropical convergence zone. Can I call in an ideal condition? In an ideal condition, can I call this as the doldrum also? Yes? But this particular wind system which we are discussing here, I told you this is in ideal conditions. Yes. So with this, westerlies, and again here you have okay. This is in the ideal conditions that I have drawn this. But apparent movement of the sun ke saath, let's try to identify how these zones are there. And always this ITCZ zone is not in the same manner. Why? Because do you have more land at the equator or less land at the equator? You have less land at the equator. When you have less land, the land gets heated fast and the water gets heated slowly. That means ITCZ zone will also form in a similar manner. Let me try to explain this. So this is in ideal conditions. That means this particular system which you have seen, this is in the month of June. September 22nd and March. Right? March 22nd or 21st. This is how your ITCZ zone will be there. But let's go to the ITCZ zone during the months of June. Right? See here. Your ITCZ, this is your equator. I am drawing the equator. Right? Your ITCZ zone will now be on Tropic of Cancer. ठीक है? This is your Africa. This is your India. Just imagine that I have drawn the globe here in this manner. So, where is Tropic of Cancer? Can I draw this Tropic of Cancer like this? Look, this ITCZ zone will be present here. It is like this. Here, this is full of water. If you want your atlas, you can open your atlas. West of Africa, you have Atlantic Ocean. Okay? Your ITCZ zone will be like this. Why? This is in the month of June 21st. Where is the sun on directly falling? Tropic of Cancer. Here the sun is directly falling over here. But on June 21st, the sun is directly falling or vertically falling where? Tropic of Cancer. So, your southeasterlies are nothing but they cross the equator. Right? This is how it is. Now, see your, what kind of winds do you have here? These are southeasterlies. Northeasterlies also there should be there, right? Now, where do you find these northeasterlies? You will find these northeasterlies somewhere here. Right? Clear? And this will be your, this is the month of June. In the month of June, you will see the westerlies as Got it? पूरा ही शिफ्ट हो गया मतलब सी दिस ITCZ zone it went little north. This is ITCZ zone, no? ये जो ITCZ zone यहाँ पे था actually it should be like this but it had shifted towards north. Sara means okay. See, it is June, right? This is your westerlies belt. Westerlies belt will become lower, shorter. ठीक है? Westerlies belt will become shorter. and this is your polar easterlies. In fact, these two belts will become shorter. Okay, you are asking that this entire belt, why is it not shifting? It is because I have drawn the ITCZ like this, right? This is how I drawn the ITCZ zone. Yes? In fact, this is how your ITCZ zone will be there in Africa. You can ask me, why is it not shifting all? It is because, look here. Look at this particular earth. Here, why is it lower here? Pani. Land gets heated quickly and cools quickly. Water gets heated slowly and cools slowly. First, suppose if the temperature is more warmer here, the ITCZ zone will form here. Right? The temperature is more warmer here. No. Water will take time to heat. Yes. Land will take time to land will take less time to heat. Imagine this is your equator. Okay? On 21st of June, where is the sunlight? On Tropic of Cancer. This is the sunlight light. Sun came from where? I mean to say, sun shifted its position from where? In fact, it is shifting its position from the equator, right? As soon as the sun comes to 21st June, will the water gets heated? It will take some time, no? But already by the month of March, April, May, the water at this particular latitude got heated. They will retain that heat. But land, by month of June itself, it got heated. Right? Water takes time to heat. This water, which is now exposed to the sunlight, it takes some time to heat. It takes a month or 2 months to 3 months to heat. And on an average, when you look into, the temperatures are more on the land as compared to water. That's the reason why. Got it? Water takes more amount of time to heat and land takes less amount of time to heat. For example, in the month of June, this is where your direct sunlight is. This is the line of direct sunlight, right? Can I call this as the line of direct sunlight? On June 21st. Water here will start to heat from June 21st, no? But ये जो पानी है, it got heated in the month of March itself because the sun apparent movement is always from where? Equators hai, it went. On the equator, in the month of March, it is at equator. I hope this all you remember. And March, May, it heated it. March, April, May, it got heated. Now June time period, it will take some time for this water. And wherever the highest temperatures are there, that will be called as the ITCZ zone. Okay? ITCZ zone is a zone where the highest temperatures or highest low pressure, wherever you find the low pressures, that is called as ITCZ zone. Now this ITCZ zone, because of the varying length of land and all, you'll get to see this variation. Means? Now Shaurya's question is that after June 21 the sun shifted southward. Why is this ITCZ zone not forming here? Yes, this water should have got heated. True. But this you will understand in oceanography because of the circulations that are happening in the water that will not let the water to heat. I'll explain this when I come to oceanography. Right? Now look at this ITCZ zone. This is the July ITCZ zone. This is January ITCZ zone. That means the one which I have drawn, this is nothing but June. Look at Africa. Look at Africa here. ठीक है. So Africa, half of Africa, it is under the influence of northeasterlies and southwesterly. So because of that, you see that look at this. Two diagrams you see. One, this is during the months of June. ITCZ shifted north. You agree? Yes. Do you agree, everyone? And this is the month of January. The ITCZ shifted southward. So look at this part of the area. There is good humidity in this time period. Too much of humidity. Now because of this too much of humidity, the people who will be living next to the equator, they are suffering a lot. Why? Because too much humidity, easily you get diseases, right? And breeding grounds of fungal, viral diseases can be more. So literally, as soon as this very hot, dry winds that are coming from the Sahara, if you open your atlas, you will find Sahara Desert here, right? Not Sahara. Sahara Desert, the wind starts to come in. Now, as soon as these winds starts to come in, dry winds, they come to this part of the area and they relieve your area from moisture. जैसा ही moisture गया, people feel that they got healed. Their diseases are gone. Itching, kujli, and that skin diseases and all, they are gone. They'll say that doctor winds, Harmattan. वहाँ का local language में Harmattan means doctor. That's why these are called as Harmattan winds. Right? So this ITCZ zone which is there, it got shifted. Now because of the shifting of the ITCZ zone, you get to see the Africa, the northeasterly winds. The northeasterly winds are now almost coming towards the equator there. So take down these two diagrams. Photo में नहीं, book में. If this is your equator, you should draw it like this. In the summers, your ITCZ zone is somewhere here. But here, you'll have the ITCZ zone. Right? Now, these are northeasterly winds. These are southwest. Right? This is the area of moisture. But here, the northeasterlies came little downward, and these are hot winds. Here they are hot. These are hot winds which are coming from the desert. So this particular area is now filled with hot and dry winds. Earlier, this was the region of moisture. This was the region of moisture. Now this moisture is no longer present. This used to be the region of moisture, right? Now, हाँ, जो ocean से आ रही है और जो ITCZ zone वहाँ पे होने के कारण आ रहा है. Usually this is in the month of June. ठीक है? This is June 20. This is June 20, and this is nothing but the January. These winds are called Harmattan winds. Draw the ITCZ little lower than equator. I did not get your question. You said that Shaurya's question is that Harmattan winds are coming from desert. Very hot and dry. They cannot bring rainfall. Yes, true. Basically, these winds which are coming in the month of, can you see these winds? ये जो winds है, these are the one which are giving rainfall to this part of the region. In fact, it is neither raining, it will not rain on a daily basis at that point of time. But humidity will be 80-90%. They don't like, people who are living in this area, they don't like. They will be waiting for the ITCZ zone shifting downward. This is ITCZ zone. To shift downward, that means the sun itself will be moving southward, apparent movement of the sun. And these hot winds which are part of the desert, they will come and they will warm up the region. Once they warm up, there won't be any rainfall. The humidity is gone. Once the humidity is gone, their diseases are gone. Now, your question is? No, they don't like rainfall. In fact, these winds which are coming, they're not giving rainfall also. Too much high rainfall they are not giving. They are increasing the humidity. 80%, 90%, 70% humidity. So, breathing problems will be there. Working will be an issue in excess humidity. You cannot sweat that easily, right, if you have high humidities. Done? Yes, March ends. – 21st or 22nd. One day it can shift. That's it. Next, Sirocco. See, Sirocco winds are those winds which are actually moving outward from desert. It is like this. Imagine this is Africa and this is your Europe. Right? This is your desert, right? Which desert? Sahara. Now the countries, if you look into, there are majorly northern part, you will have male countries. Did you find male countries? Morocco, Algeria, Libya, Egypt. They are called as male. And Tunisia also here. Small, one country. T-male. So these countries, especially from here, sometimes the wind moves in this direction. The wind which is moving towards Africa, from Africa towards the Europe. Now these Sirocco winds are hot winds. But these Sirocco winds, when they entered into a sea called Mediterranean Sea, they pick up moisture. Okay? They pick up moisture means the hot winds, they'll take the moisture from the sea. Warm and moist. Right? Now this air, what does it do is, it will go and shed its rainfall here. मॉइस्चर पानी लेता है यार, यहाँ से गर्म हवा जा रहा है, ठीक है, हाँ, गर्म हवा जाते जाते मेडिटेरेनियन सी में इट विल पिक अप वाटर बिकॉज hot air has the tendency to hold more moisture. This warm air, while it is moving, it will pick up the moisture from the Mediterranean Sea because Mediterranean Sea में evaporation हो रहा है. Now that evaporation which is there, it will go towards Europe. Now in the Europe, what does it do is it starts to rain. Now when it rains, it is called as blood rain. Here it is called as blood rain. Why? Color. Very good. It is because of the blood rain. Yes? Because Sahara का मिट्टी जो होता है ना, that is also carried with this dust. Now, when that moisture is taken, sometimes this rain, while it is falling on the roads and all, it looks red color. Why? Because the mitti, that is sand from the Sahara, is being carried through these winds and moisture is picked and it will deposit here. It is also called as blood rain, and this rain is very, very good for horticulture. ठीक है, especially viticulture. Wine तैयारी होता है ना, grapes and all. It is very good for in the northern hemisphere, in the southern part of Europe. So online there is a question. Sir, ITCZ shifting position according to the position of the sun, and the whole monsoon phenomena is completely established on the location of the ITCZ. Yes, very good. This is what is it, Avijit. Avijit ne पूछा, sir, ITCZ shifting north. So that means the entire monsoon phenomena is also dependent on the ITCZ zone? Yes. Entire monsoon phenomena is also shifted in the ITCZ zone. Right? Wait for 2 days, you'll understand all the concepts. In geography, this is like it. Every day you'll learn something and it will clear your previous doubts. Right? So what is this called? This is called as Sirocco. Look. From here, the winds are moving, especially the male countries, Morocco, Algeria, Libya, Egypt, and tea, male tea. Got it? So it will go and rain in this Madrid, Spain, Italy, Rome, France also. Now when it is raining, you know that vine is very well grown here. This helps in the cultivation of grapes. And it will also make the soil little fertile. Why? Because the sand from this is being carried and deposited there. When the desert sand gets water, they turn very fertile. Okay? If desert soil, if you are going to give water for near about 30, 40, 50 years, that is the world's fertile soil you will ever see. Because desert has so many minerals. The sand has certain kind of minerals. All it needs is water. Water मतलब आज पानी दिया कल पानी दिया वैसे नहीं. 30, 40, 50 हजार पानी दो चल जाता है. गंगानगर डिस्ट्रिक्ट, are you aware of that? Ganganagar district, Rajasthan. It was a desert area, but today it is a green revolution area where they are taking 3 crops in a year. Why? Indira Gandhi Canal. Indira Gandhi Canal is present there. So I want you to remember these. Now let's come to India. Right? In India, majorly you find mango. Here it is oddly written. Mango showers are basically here. And these are blossom showers. Andi. It is also called as Lu. If it is Andi, when it is creating dust storms plus thick dark day, it might create in the evening, 4 p.m. itself. Right? That is called as Andi. Isi winds in West Bengal, they are called as Kal Baisakhi and Bardoli Chera. Okay? Bardoli Chera, they are called in Assam. Basically, look here first. Let me explain. This part of the area is desert, right? When the deserts get heated, locally what happens is that they'll throw out the air. Okay? They'll literally throw out the air. So that's the reason why, because of excess heat here, because of local conditions, here north mein Himalayas are there. The heat cannot dissipate anymore north. So that's why the wind which is there, it will be spread over this part of the region. Okay? Because the wind cannot move anymore north. So that's the reason why the entire hot winds which are present in this part of the region before the onset of the monsoons, that too in the month of May. Lu, abhi jo hawa chal raha hai bahar, it is called Lu. Right, in the northern part of India, 2 hot winds, everyone will start to cover their faces with clothing and all. That is called Lu. Now Lu has different names. Andi, Tufan jaisa with wind storms, with sand storms, sometimes at 4 p.m. or so, you will see the dust is all around in the air, right? That is called as Andi, without any moisture. Kal Baisakhi, it is called in West Bengal. ठीक है? Bardoli Chera in Assam. They are all hot winds, they are local winds, they are also convectional winds. ठीक है? Convectional winds means on a daily basis the air is getting heated, but there is no moisture. What happens? If there is continuous heat that is taking place in a particular area, ठीक है? But there is no moisture present in the atmosphere, what happens then? Dust storms. Water to hai nahi, to it will start to move the dust here and there. So all these are dust storms. Andi, Lu, Kal Baisakhi. It gives Kal Baisakhi and Bardoli Chera, they have little moisture, and rest of them, mango showers and elephanta showers, are local convectional rainfalls. Elephanta showers are also called as the mango showers. ठीक है? Mango, it is written here. Elephanta or mango, both are same. Mango showers, they are called mango showers because these are also called pre-monsoon showers. Now, what do you mean by pre-monsoon showers? Before the onset of the monsoons, you will see the rainfall in that part of the region because of convectional heating. Continuously the land got heated. If there is water bodies present, that water bodies will lead to evaporation, and evening it will rain. Now that is called as mango showers, and these mango showers, they are called mango showers just because the mango flowering mein madad karta hai. In Kerala. In Karnataka it is called as blossom showers. Now these blossom showers, they help in flowering of coffee. Karnataka has coffee plantations, it is called flowering of coffee. In the month of May, if there is convectional rainfall, that convectional rainfall in Andhra Pradesh, in Kerala, it is called as mango showers. In Karnataka, it is called as blossom showers, because in Karnataka and in Kerala and in Andhra, mangoes are widely grown. So that's why these showers will help in flowering of the mango. They are called as mango showers. But in Karnataka, there are mangoes are less, but coffees are more. So that rainfall is also called as the blossom showers, because the coffee flower is blossoming. Right? Now these are local winds. So all these local winds, you need to know, this is a representational image of Lu and Andi. Rajasthan hai, mitti dekho pura, satellite image. Here, this too much of sand will be there here. That's why it is varying. Satellite images ho, it depends. Right? Now let's quickly go and take the notes of I need to give the pressure belts notes. Turn which notes you want. कौन सा? Maritime polar, I have given the notes. For temperate cyclone, I have given the notes. So general circulation of atmosphere, did I give? General circulation of atmosphere notes. I have explained. I know I have explained in very, very detail. But did I give the notes? I have not given the notes. So let's quickly take the notes. Give a heading as general circulation of atmosphere. Write down quickly, huh? Okay? I have given for factors that are influencing the distribution of movement of the winds, right? Factors that are influencing the movement of the winds. Did I not dictate what are the factors that are? Huh? Last dictation? Clouds. Now first give a heading as factors within the global atmospheric circulation itself. Write down factors affecting wind velocity and direction. Factors affecting the wind velocity and direction. Write down. Air in motion is called as wind. Air in motion is called as wind. Air in motion is called as wind. As wind blows from high pressure to low pressure, as the wind moves from high pressure to low pressure, this wind experiences three forces. This wind experiences three forces in addition to gravitational force. This wind experiences three forces in addition to gravitational force. First one, pressure gradient force. First one, pressure gradient force. The rate of change of pressure within that, the rate of change of pressure with respect to distance. The rate of change of pressure with respect to distance is called pressure gradient force, or PGF. Is called PGF, or pressure gradient force. The higher the PGF, more is the velocity of the wind. The higher the pressure gradient force, more is the velocity of the wind. And larger is the deflection of the wind. And larger is the deflection of the direction of wind. Larger is the deflection of the direction of the wind. Second, frictional force. Wind at the surface experiences friction. Wind at the surface experiences friction from 0 to 3 kilometers. Winds in the higher atmosphere experience less friction. Winds in the higher atmosphere experiences less friction. Full stop. Next point. Friction impacts the speed of the wind. Friction impacts the speed of the wind. Friction impacts the speed of the wind. Next, third one, Coriolis force. Coriolis force. The rotation of the earth on its axis, affects the wind direction. The rotation of the earth on its axis affects the wind direction. It deflects the wind towards the right in the northern hemisphere. It deflects the wind towards the north, the wind towards the right in the northern hemisphere, and towards the left in the southern hemisphere. It deflects towards the right in the northern hemisphere and towards the left in the southern hemisphere. Next point. The Coriolis force is directly proportional to the angle of latitude, or directly proportional to the angle of latitude. Which means comma, which means comma, the Coriolis force deflection is maximum at poles. The Coriolis force deflection is maximum at poles and minimum at equator. And minimum at equator or absent at equator. ठीक है? Clear with this? Next point. Write down. General atmospheric circulation. General circulation of the atmosphere. General circulation of the atmosphere. That means you can also draw this diagram at the Coriolis force point. This one. Okay? Write down. Air at the intertropical convergence zone. The air at the intertropical convergence zone rises because of the convection, rises because of the convection caused by high insolation and low pressure. Convection because of high insolation and low pressure. Full stop. The wind from the tropics of both the hemispheres, will converge at the low pressure zone, will converge at the low pressure zone of the ITCZ. Will converge at the low pressure zone of the ITCZ. Next point. The converged air at the ITCZ, at bracket में लिखो at the ground, will now rise along with the convectional cell. It reaches to the top of the troposphere. Up to an altitude of 14 kilometers. It reaches to the top of the troposphere up to an altitude of 14 kilometers. Full stop. And it tends to move towards the polar side. Thus, this movement of air towards the polar side, accumulates at about 30 degrees north and south, about 30 degrees north and south. Part of the accumulated air sinks to the ground. Part of the accumulated air sinks to the ground and forms a subtropical high pressure belt. Part of the accumulated air sinks to the ground and forms the subtropical high pressure belt. Next point. Do you understand what I am talking about? Okay? There's no confusion, right? Till now I have told you why it rises and then it sinks. Right? Now write down next point. The another reason for sinking is the cooling of air when it reaches to. Another reason for sinking is cooling of air when it reaches to 30 degrees north and south latitude. Cooling of air when it reaches to 30 degrees north and south latitude. Okay? Here, the air that sank will now move towards the equator. The air that sank will now move towards the equator. The air that sank will now move towards the equator to fill the gap. Okay? Thus, these winds at the ground are called as northeasterlies and southeasterlies. And these winds converge at ITCZ zone. Right? Such circulations, write down, such circulations from the surface upwards, and vice versa, from the surface upwards and the vice versa, are called as cells. Vice versa are called as cells. The cell which is formed between equator and Tropic of Cancer. The cell which is formed between the equatorial low pressure belt, and the subtropical high pressure belt. The cell which is formed between the equatorial low pressure belt and subtropical high pressure belt is called the Hadley cell. Next point. In the middle latitudes, the circulation is that of sinking cold air. In the middle latitudes, the circulation is that of sinking cold air that comes from the poles and blows towards Okay, that comes from the poles, whatever you have written, just strike it. That comes from the poles, you have written. Strike down and goes towards, write down. And the rising warm air that comes from the poles, and the rising warm air that blows from the and the rising warm air that blows from the subtropical high. Full stop. At the surface, they are called as westerlies. At the surface, they are called as westerlies. And the cell is known as the Ferrel cell. And the cell is known as Ferrel cell. Okay? Next. At the polar latitudes, next point, at the polar latitudes, the cold dense air, at the polar latitudes, the cold dense air subsides near the poles. At the polar latitudes, the cold dense air subsides near the poles and blows towards middle latitudes. Subsides near the poles and blows towards the middle latitudes as the polar easterlies. And this cell is called as polar cell. Okay? And these cells are called as the polar cell. Next point. These three cells, bracket में लिखो, Hadley, Ferrel and polar. These three cells, Hadley, Ferrel and polar, form the general circulation of the earth, form the general circulation of the atmosphere. Forms the general circulation of the atmosphere. And this general circulation of the atmosphere helps in the distribution of heat from lower latitudes to higher latitudes, and vice versa. From lower latitudes to higher latitudes and vice versa. Can you read the previous point I have dictated about the middle latitudes? Read it for me. In the middle latitudes. Can you read it again? In the middle latitudes. Slow. In the middle latitudes, the circulation is that of sinking cold air that is coming from. Okay. And the rising warm air that blows from the subtropical height. Okay. What do you mean by that? Do you understand? Cell ban gaya. I'm talking about this wind. Okay? I'm talking about this wind and I'm talking about this wind. Okay? You can also write in your own words. It's not that whatever I've dictated, this is what you have to write. You can also write it in your own words. I don't mind. But this is only for your reference. Right? Quickly draw the diagram. पहले बनाया ना, यहाँ पे बनाओ, कोई दिक्कत नहीं, दोबारा बनाओ. If I give the notes in the printed format, will you add it to your copy? Pakka? Online? Everyone? If I give the notes in the form of printed copy, only this part of the notes, will you add it to your notes? Okay. I have already shared certain files to you online if anyone has checked. Portal pe. Online, anyone checked on the portal? I've already shared a good chunk of notes for you, printed format. Yes. From there also you can add notes, not an issue. And in the next class, we'll learn about monsoons, okay? And the types of rainfall. Tomorrow's class, it is monsoons and types of rainfall we'll learn in detail. Done? We'll stop here today and tomorrow we'll continue. So a fresh topic, monsoons, and before that, a couple of pages of notes are there that also I'll give you. We'll complete fast and then we'll move ahead. Right? Okay, online. Thank you. We'll stop here and tomorrow we'll continue. Yes, sir, I have checked. Avijit, thank you. Thank you, online. We'll end the class here.